Okay, so one last empirical strategy that I wanted to just touch on briefly, and that's this idea of a regression discontinuity. So there's a couple different types. The simplest version of this is a sharp regression discontinuity. And the basic idea here is you have a treatment that is fully determined by some sharp cutoff in an assignment variable. So think of something like there's a test, maybe there's a test to get into the Army, and there's a sharp cutoff in whether you're accepted or not, right? And so if you're on it, if you're 1 point below, you don't get the treatment. If you're 1 point above, you do get the treatment. So in this case, we're assuming the assumption here, like to build our counterfactual, right? The idea here is we're looking very close to this cutoff, and we're saying that which side of the cutoff you fall, if you're really close to the cutoff, is as good as random, right? Or in other words, we've got an apples to apples comparison of people just above and just below the cutoff, right? And so people just above the cutoff that get the treatment, we're going to, as a counterfactual for them, we're going to use the people just below the cutoff that didn't get the treatment, right? So it's a pretty simple idea, and you can sort of see it graphically very nicely, which is why it's become very popular in economics. So here's an example. We've got a sharp RD estimate of minimum legal drinking age on mortality, right? So this is the death rate from all causes per 100,000, and you have that 21st birthday right there. And the basic idea here is people just below age 21 look a lot like people just above age 21, except people above age 21 are able to legally drink. And you see this bump up in the mortality as a result of that. So that's a sharp RD. There's also a fuzzy RD, which is a little bit more complicated. It's basically a flavor of our IV estimate. And here, you don't have the treatment fully determined by that cutoff. It's partially determined. So if you're on one side of the cutoff, you're more likely to receive the treatment than if you're on the other side of the cutoff. So here's an example from a journal article that was looking at the effect of placing students into like a tracked, I think it was a tracked 4th grade classroom. So, split, they end up in sort of the higher, the more difficult classroom, right? The more challenging sort of classroom with higher ability peers, right? But there's some cutoff in terms of who gets it, right? It has to do with the rank of the student in the class, right? So we've got this cutoff, right? And if you're a little bit above the cutoff, you're, more likely, right? This guy here is 60% going to end up in that classroom, whereas this guy over here is only, 23% likely to end up in that tracked classroom, right? So it's not fully determined, right? If we were to have done the first stage for this, who is treated with this with the legal drinking, it would look like 0 and then 1, right? Because the treatment would affect everybody on the other side of the cutoff, as opposed to here where it doesn't affect everybody. So that's the first stage for this fuzzy RD, and then the reduced form, we're looking at the outcome versus the assignment variable here. So if you're on the left side of this cutoff to get into the classroom, you're getting less, you're getting a lower score than if you're just on the right side. So the treatment effect that we're after, and again, it's going to be a local average treatment effect. If you remember when we're talking about IV, the reduced form piece of that is going to be the difference between where this line falls and where this line falls. That's our treatment, or that's our reduced form here, right? For reading. And we've got a similar one for math, right? So those would be our reduced form estimates. Remember, we would divide those by our first stage estimates to back out that that estimate of the local average treatment effect, right? The effect of being put into this this tracked classroom on reading and math. At least 4 people, and this is the local part, 4 people that are like close to that cutoff, right? Because those are the only people that we're sort of using the variation from to get this estimate.